Hi, welcome to Chainlines. Today I'm going to explain a real Bitcoin transaction. At a high level, a transaction is just moving digital value. It destroys old coins, which we call inputs, and creates new coins with new locks, which we call outputs. Here on the left, you can see the inputs. This is the money being spent, and on the right are the outputs. This shows who's receiving the money, basically the destination addresses. Notice that the inputs are slightly higher than our outputs. That missing slice is the fee which get paid to the miners for processing the transaction. We also have a fee rate, which is the fee divided by the transaction size. Mm, in Bitcoin, the size matters. The more data bytes you take up, the more you pay. This transaction uses SegWit, which is an operator that separates the heavy signature data, the witness, from the main transaction. Because of SegWit, the transaction ID and the witness transaction ID are different, and this user got a SegWit savings discount on their weight. Bitcoin uses different types of locks. For example, here we see P2 WPKS. This is standard security addresses and P2SH. The most modern privacy focused locks tap it as well in some cases. You might also see OP return, which is a way to permanently burn a tiny amount of coin to write arbitrary masses on the blockchain. Here we can see the RBF flags. This transaction also signals RBF, meaning it's replaceable by fee. The sender can pump the fee later if it gets sock. We also have a time lock. The time locks can be absolute, meaning this can confirm until a certain date or block height, or relative, meaning an input has to wait a certain amount of time after it was created before being spent. Finally, if the user underpaid their fee or sent dangerously small dust, our system will trigger a warning at the bottom to give them same. For now, this is the RDF signaling one, and that's the anatomy of the Bitcoin transaction, visualized cleanly without the complex code. Thanks for watching.